In this video, I will explain you the effective focal length in the combination of lenses. I have two lenses kept one after another. So in this arrangement, I am going to check what would be the effective focal length. In this case, lens 1 is having a focal length of f1 and lens 2 is having a focal length of f2. So what is actually happening behind the scene when the lenses are connected in this way? See, when this lens is not present, a ray from object would go towards the lens, and after refraction that would go and create an image at I1. So I have one ray in this way and I have another way in this way. This ray is passing through optic center, so that would be undeviated. So second ray would be here, I would have my image created here. But this ray, when it was going away from the lens 1, it met lens 2. So what will happen? This would be again bent by lens 2 and this now will create an image here. So the refracted ray was supposed to go in this direction, but as a lens is present in between, the lens has done one more work of bending the ray to a new direction and creating a new image, which is at I. Okay, now I will apply the lens formula for lens 1. So applying lens formula for lens 1. We know the lens. What is the lens formula? 1 by V minus 1 by U is equal to 1 by F. So just substitute the values. What is 1? Okay, what is V, U and F? V is equal to image. So this lens would create an image here, which is, so okay, I have to take the measurement from C1 in the case of lens 1 and C2 in the case of lens 2. So I brought a new point here, which is a point of reference for both the lens. So all the measurement I would be taking from C, which is an average of C1 and C2. So instead of C1 I am going to take it as CI. So V is equal to Ci, and that is measured in rightward direction, so positive. And what is U? That is O, C1 actually, so that would be OC here, and OC is measured in leftward direction, so that value would be negative. And F, focal length of this would be, anyway for convex lens it would always be positive. So F is equal to plus F1 itself. So just substitute the value in this. So 1 by Ci minus 1 by U is OC, and that is minus. So this minus would be here. This minus and minus would become plus, and that is equal to 1 by F1. Similarly, applying lens formula for lens 2. Applying lens formula for lens 2. So for lens 2, this OI1, that is image created by lens 1, will act as an object for lens 2, and that would create an image at I. Okay, so the same equation, but there V will be equal to image is created at I, and that is Ci plus Ci. Why? The measurement is taken in forward direction. Now what is object? Object is nothing but image created by lens 1, which is Ci1, and anyway that is measured in rightward direction, so that would be plus Ci1. And focal length is equal to F2. For this lens, that would also be positive because that is a convex lens in my example. So substituting in this equation. So substituting in which equation? 1 by V minus 1 by U is equal to 1 by F. On substituting in this equation, so this is now being substituted here, and we will get a new equation like this, which is 1 by Ci minus of 1 by U. U is 1 by Ci1. Okay, 1 by Ci1 is equal to 1 by F2. I have one equation in this way and another equation in this way. See, I have plus 1 by Ci here. Okay, here Ci1 would be my image. Okay, Ci1 created by lens 1. Lens 1 is creating an image at I1. Okay, it's not at I, it's at I1. So Ci1 would be my image. Okay, so I have plus 1 by Ci1 here and minus 1 by Ci1 here. So on adding, these two will cancel. So 1 plus 2 would be Ci1 and minus Ci1 has cancelled. I have 1 by Ci plus 1 by OC is equal to 1 by F1 plus 1 by F2. What is 1 Ci? Ci is my image distance. Okay, the actual image distance. So that is 1 by V of equivalent. So instead of this, I am just considering these two by a single lens. Now that is also creating an image at I. So in this case, this distance would be my image distance plus V, and this distance would be my object distance minus U. So OC is actually object distance, but in equivalent lens, when I am considering this as this, it would be minus U. So plus 1 by OC is minus U. This is equal to 1 by F1 plus 1 by F2. So this is equal to, this is U equivalent. So here 1 by V equivalent minus 1 by U equivalent is equal to 1 by F1 plus 1 by F2. So actually 1 by V equivalent minus 1 by U equivalent was supposed to be 1 by F equivalent. Instead of this, I have 1 by F1 plus 1 by F2. See, this would be the effective focal length. So if lenses having F1, F2, F3, F4 connected in this way in series, then the effective focal length 1 by F effect equivalent is equal to 1 by F1 plus 1 by F2 plus 1 by F3 etc. till 1 by Fn. Okay, so 1 by F equivalent is nothing but P equivalent, power equivalent. This is equal to 1 by F1 is P1 plus 1 by F2 is P2. This is a very important relation. 1 by F equivalent is equal to 1 by F1 plus 1 by F2, or P equivalent is equal to P1 plus P2. If there are n number of turns, then P1 plus P2 plus P3 plus P4 plus till Pn. Okay. Now, if one is convex and another one is concave, and if both one convex and another concave connected in this way, and if both one is having a focal length of f and another one is also having focal length of f, but we know that in the case of convex lens that would be plus f, and in the case of concave lens that would be minus f. Focal length would be negative for concave, positive for convex. Now what will happen? This equation, the effective power is equal to P1 plus P2, or 1 by F equivalent is equal to 1 by F1 plus 1 by F2. Now 1 by F1, first one is convex, so that would be 1 by plus F, and next one would be plus 1 by F2. This is concave, so that is minus 1 by F. So this is equal to 1 by F minus 1 by F, so this would be 0. So power is equal to 0, which means power is equal to 1 by F equivalent. So 1 by F equivalent is equal to 0. So 1 by a value is equal to 0. So a number divided by another number, if it is 0, this number have to be, either this have to be 0, but this is not 0. So 1 by F equivalent, sorry, F equivalent has to be infinity. Only when this is infinity, 1 by infinity is 0. 1 by any value would be a positive value, or I mean a non-zero value. Only when infinity come here, that would be 0, which means this is having an infinite focal length. So any ray which is coming towards it, that would only be focused after infinite distance, which means that would never be focused. They are parallelly approaching, and after refraction they would go parallel. What is the meaning of this? There is no refraction occurring here. This would simply behave as a slab, and rays are coming towards the normal, and after refraction they would go in the same direction. Okay, so these are the practical examples. Thank you.